And welcome back to another thrilling episode of Math 3 Honors. We are in Unit 2. I know you're excited. We're talking about polynomials, and this lesson is just basics of polynomials. So first thing you need to know is what a polynomial is. So polynomials are written in this form. So a subscript n times x to the n, a script n minus 1 times x to the n minus 1. And it just keeps going and going until you get like a1x plus a naught. These terms, an minus 1, a1, and so on, those are just the coefficients. So the coefficients, first off, must be real numbers for this to be a polynomial. And then the exponents must be whole numbers. Or 0. So we usually say are non-negative integers. So non-negative integers. Okay. Now, standard form, you probably already know what standard form, that just means we're writing in order. So it's written in order. So highest exponent to lowest. Ooh, that was a really good W. Okay. When we talk about degree of a polynomial, we're always talking about the highest exponent. And then the leading coefficient is the first coefficient when the polynomial is in standard form. Meaning it's got to be the coefficient of the term with the highest exponent. Okay, so those are kind of your basic definitions. So another thing we talk about just as an introduction before we do any example problems is end behavior. So end behavior is your vertical direction of both ends of the graph. We've talked about this last unit where we would say, like, for instance, this graph, we'd say as x is approaching negative infinity, or as we go to the left side, while the y values would be going up, so they'd be going to infinity. And then as x approaches positive infinity, or as we go to the right side, our arrow once again is going up, so we'd say y is approaching positive infinity because it's going up. Okay, so that was the official way of writing end behavior. For the intents and purposes of this unit, we're going to simplify that all together. And we're just going to go ahead and say the end behavior of this function right here, and this is a quadratic, would be that the graph is going, the arrows are going up and up. Okay, so that's going to be important because I want to build something so you understand why the end behavior behaves the way it does. So when we talk about polynomials, we all know what y equals x looks like. That's just a straight line that looks like this. So you'll notice on the left side, so the left arrow versus the right arrow, the left arrow is going to be going down, while the right arrow is going to go up in this graph. Okay, but then if we go to like y equals x squared, you guys know that's a quadratic, looks like this. Well, in this case, both the left and the right arrow would be going up. I should split them up this way. Well, if we do y equals x cubed, this is a function like this, and we've seen that graph before too. And once again, it's actually just like the line, except the end behavior is just like the line where the left arrow goes down, or the left side goes down, the right side is going up toward infinity. Well, if you draw y equals x to the fourth, if you just draw just x to the fourth, it looks similar to a quadratic. It's just steeper because it's growing faster. So notice it's going up and up. So what you're going to notice is there's this very specific pattern based on the degree, so the highest exponent of each one of these. Okay? So if you have an odd degree versus an even, I'm going to write even first. Even degrees, they're always going up and up, right? Odd degrees, they're going down then up. Now, it does change, though, if your leading coefficient switches. So if we switch these to, like, negatives, so like a negative x, for instance, would mean the arrow's going down. Negative x squared means the parabola is flipped upside down. meaning these arrows or the end behavior will flip directions. Okay, so that's for negative leading coefficients. This is for, I'm going to call it leading coefficient like that. Sweet. So I'm going to erase that. One last thing you got to know is there is something called a maximum turning point. That just means how many times is it switching from like increasing, decreasing, and so on. So I'm going to call maximum number of turning points because I want to abbreviate that. So if it's just a line, there's not one. It's always increasing, it's always decreasing. Quadratics will always look like parabolas, so there's always this 1 point, it's the minima. Now cubics, if I like add some extra terms onto this, you can actually have a cubic that looks something like this. And you'll notice there are 2 turning points total. Quartics can look like parabolas, but they can also look like a little W if you add some other terms on and such. And so you'll notice there are 3 turning points. What you're going to notice is the maximum number of turning points is always 1 less than the degree. So let me move that down. It's kind of in the way. There we go. Okay, so we got like this little end behavior chart I've made. We have an understanding of maximum number of turning points. So in the next few videos, I'm just going to go ahead and do examples to kind of show you how this works.